Low class.
Hello, Mr. Sylvester.
All right. Who is this?
Andrew Law.
Oh, okay. All right. How you been?
All right. How'd that storm treat you?
Oh, I was all right. I did, fared well. Just couple of branches fell, but everything else was all right. What
That's
about
good.
you?
Not bad. Had a little bit of trash in the yard had to pick up, but on
Right.
that, only lost power overnight. That was it. So
Oh,
thankful for
yeah.
that.
Okay. Yeah. Our power kept flicking on and off. It did it about, I'd say 15 or 20 times on and off. Go
Oh, wow.
off, go back on. Yeah, yeah. But we did all right. Yeah,
Nice.
but a lot of people in like the Opelousas area, Lafayette area, they had a lot of trees down. Yesterday, what it was yesterday? Yeah, I went down there yesterday. Some people still didn't have lights and stuff.
Jesus.
Yeah, I'll tell you, bro. Yeah,
That's crazy.
I know. Yeah. Oh, yeah, we'll get through it though, some kind of way. Yeah. So how many people are logged in? Let's see. 6 people, yeah.
Professor Sylvester?
Yeah, who this?
It's Ashley
Ashley, last name.
Moker.
Okay, Miss. This is my first time talking to you, huh?
Not quite. I've talked to you a little bit, not a whole lot.
Okay, all right. What you got?
I just wanted to let you know that I'm gonna have to leave the Zoom meeting at about 1. I have to take my son to the doctor.
Okay, no problem. I normally post the thing and whatnot.
Okay, gotcha.
It'll be fine. It'll be fine. Yeah. But let me see. I think he was what? If I'm not mistaken, let me go back. I assigned the program for chapter. Oh no, I got to grade the program for chapter 4. I think got to finish grading that to do my midterm grades. Let me go back. Let me go to more grades.
Do you think we'll be having a test this week?
Yeah, let me. I'm gonna see how far we didn't start a new chapter. Huh? We was in a chapter, and we was in the chapter.
I think we're finishing chapter 4.
Right. See, that was saying. So if I was toward the end, yeah, because we had to go over case statements and whatever. Yep. So yeah, we're gonna finish up that, and then we'll have a test. Yeah, we'll have a test on chapter 4. Yeah, and y'all, let's see, the programs were due on the 5th. So anybody had issues with the program? Wait, no, the program wasn't due on the 5th. Let's see what the program was done. On the 6th.
They were doing the 6th.
Right, the 6th. Right. Yeah. Any problem with the program? One of them was on the 5th, but should have been the 6th. Any questions about the program? No questions? Okay. So we'll move on. So let's get to, and any other questions? Anybody have any other questions? So let's look at the chapter. Chapter was that? Chapter. I need to share my screen too. Chapter. Yeah. Oh yeah, we're at the case statement. So let me share the screen. Where am I? On my Zoom. All right, let's see some share screen. Okay. All right. So, and we had talked about ifs. We had talked about the logical, what the and the or, the not, and all that, right? And then we showed how we can compare or combine if logic, where we can say if x is greater than y and z less than 3. We can evaluate those to be either true or false. All right. So the case statement. All right. So let's look at the case statement. Now, recently we had written a program dealing with grades. You know why you asked if it's, well, and it was some other stuff too. And we had if this, if this, if this, if it's this. So with the case statement allows you to take a value, all right, and then compare it against a certain value. And based on that value, you can do execute certain commands and then break out, or stay within it and eventually break out. Or if none of those cases come to be true, you have a default to say do whatever. So the switch statements let values of a variable be or an expression determine where the program will branch. Okay, and this is just an example of how that will work. All right, the format would be switch, which is a command, and in parentheses you can put your integer, your value, or an expression. Okay, based on that value and expression, then you could say case whatever. If it's I don't know, if it's like, say if it's a number where we did the menu, case 1. If it's 1, we're gonna do this, that, whatever. We could call a function. And we'll get to that later on. We could execute, see out this, see out that, add this to this, whatever, and then break on out. And we could have case 2. Right, if it's case 2, do this, do this, do this, do this, do this, and exit out. Case 3, do this, do this, do this, and exit out. What was that command? Break out. Or if it's neither one of those cases, then by default, you must have entered an invalid option or whatever. And like I say, if you look, whatever your expression is or your value, put it in your variable, you put it in here. Your switch statement is embodied in the body is embodied in curly braces, open curly braces, close curly braces. Then you have case, whatever, semicolon, and then whatever statement you need to have in the C++ format. And then normally you would break, depending. We'll see how sometimes you may not want to. Then you have your next case, statements, and then your next case, it's statements. And if it's neither one of those, then by default, it's something else, or usually invalid. So let's look at it. All right. It's we can look at this after the word case. The expression of each case statement in a block must be unique. So that means you cannot check for the number 1, something if it's equal to 1 or the letter A, and then later on you're asking if it's equal to the letter A again. You're kind of defeating your purpose. All right. So they must be unique in these case situations. They should be unique. All right. The expression following the word case must be an integer, literal, or constant. So whatever your expression is should yield you a value. All right. Should yield some value. All right. So it says the program branches to this section if none of the statements. Let's see, what was that? It branches to this it branches to this section if none of the case expressions match the switch expression. Okay, that would be the default. You remember, and I can show you a default. If choice, and that's just a variable, not an expression. That you allow a user to input a value. It's stored in the choice. Switch in parentheses choice. So that's saying, okay, we're gonna check choice. Then it says case, being that what? It's char, we have to use single quotes, right? So being that it's char, you use single quotes. So you comparing A to what was inputted for choice. B, what's inputted for choice. C, what's inputted for choice. If it's neither one of those, it's gonna say you did not enter A, B, or C, right? But if the person enters the letter A, then you must you enter A, and then break will take you out and do the return 0. All right. If you put B, it'll check to see if it's A. It wasn't A. Check to see if it's B. Oh, it's B. you entered B, break, kicks you out. Then if it's C, you put in, you check here, kick out, check here, kick out, check here. Oh, okay, you entered C, break, right? But what happens is if I wouldn't have put a break here and here, like after checking for A and B, it would do check this, but then it'll go down and it'll actually try to perform whatever you have here, like you entered A. Case B, it'll print out you've entered B. And then case C, oh, you entered C. So you gotta make sure. Now watch, look at this. This is the example. This is the code, right? Simple program, choice is a variable. You enter the value for choice variable, and you're checking for A, B, or C, or if not, okay. So now it says if they enter B, what? You've entered B and you exit out. In this one, they entered F, you did not enter A, B, or C. All right. So now they're saying the first case statement, all right, is case A. The second one is case B, and the third is case C. These statements mark where the program is to branch if the variable choice contains those values, A, B, or C. Remember, character variables, right, or literal, and literals are considered integers, right? And what that means is the letter A, the actual value is what, 65. So even though you're putting in the A, the system converts it to an integer value, right? So the default section is branched to if the user enters anything other than A, B, or C. So it's just telling you, okay, it actually goes to the program, check to see if it's A, and then if it is, and then it breaks out. B, and it breaks out. So, but down here, the case statements show the program where to start executing in the block, and the break statement shows the program where to stop, okay? Without the break statement, and see, this is the part I'm trying to stress. Without the break statement, the program will execute all of the lines from the matching case statement to the end of the block. So the example I gave before, if I took break out here and took break out here, it's going to perform all of the C++ statements that I have after this case, and if it's C, it's going to execute these cases. So if I took break out from this statement and break out this particular statement, and I ran the program and I put letter C, it's going to say you entered A, new line. They're going to go here, you entered B, new line, and then it's going to say, oh, it's C, you entered C, new line, break, and then it's going to break. So you're going to have conflict, not say conflicting, but confusing output, all right? Well, it's going to say you entered A, you entered B, and you entered C, which really you just entered C, but you didn't what? You didn't put the break statement in there so to break off those sections. So let's look at it. So looking at this program here, now it's the exact same program minus what? Break after each one of the cases. And if we look here, we got case A, break. Case B, we outputting something, but break at the end, the very end. Case C, break. But then we look down at this program, exact same program, case A, output, case B, output, case C, output. No breaks anywhere in the program. But notice what happens. They put in the letter A, and what happened? You entered A, you entered B, you entered C, you did not enter in. Because what? There's no breaks anywhere in the program. Now, sometimes you may want to have more than one case to where you don't break off until the second case or the third case. But in this instance, I want to check to see if it's A, and if it's A, then kick out. If it's B, then kick out. If it's C, then kick out. All right? So that break becomes very important. Without the break statement, the program falls through all of the statements below the one with the matching case expression. All right. So let's look at this one. This is a small program, and what this program does, it allows a person to, well, I wouldn't say a person, it allows a cashier or whomever to put in a certain model television set that a person is to buy. And not say model, but option. Like one option, if you look at it, our TV comes with three models, three different models, a 100 model, a 200 model, and a 300 model. And that could be other different models, whatever, but they just use those numbers, just to use it. So when the program is ran, it asking them to input the model that person is buying, okay? So they'll put in the model. But look at this case statement here. Now, what they did, they reversed the numbers, which is cool, no problem. Like I said, you're just checking from 300 to 100. You could have did from 100 to 300. But notice why they did it, all right? If you're buying a model 300, you're going to get the picture-in-picture. You're going to get the surround, the stereo sound, and you're going to get the remote. If you buy the 200 model, you're going to only get the stereo sound and the remote control. If you buy the 100 model, you're only going to get the remote control. All right. So what did they do? They said, okay, if they buy the 300 model, okay, case. All right, here we go. Whatever model was inputted, case model number. Switch model number, and then case 300. What they're gonna output? Picture-in-picture is what they're gonna get. They're gonna get stereo sound. Remember, it's gonna execute everything until it gets to the break. Remote control, they're gonna output that. Then it's gonna break. But then if you notice, if they choose or input 200, model 200, all right, it won't start here. It'll start from the one where it's valid, right? It's gonna fall here and says, okay, stereo sound and remote control, and then break. All right. So let's look at it. All right. So it says, okay, they put 100. Right. This model has the following features: remote control. So what happened? When it matched the 100, then it just printed that one and kicked out. Okay. Wherever it matches, it's gonna do from that point on till it see a break. So, and this one says, okay, they outputted 200. So when they not output it, but they actually entered model 200. So therefore, okay, it's 300. No, oh, it's 200. I gotta fall in here. I'm gonna output stereo sound, and then I'm gonna output remote control. So see, and that's what they got here. And then if it's the 300 model, see, they got what? The picture-in-picture, because it fell in here. There's no break. Fell in here. There's no break. Fell in here. Oh, break and kick out. All right. So, and they put 500. You only have these choices. So this is how the case statement works. All right. So that break becomes important, and that break can be used, to manipulate your data. All right, where you can have multiple choices. So look here. This is another way you can use the break statement and even the case statement, because many times when we're doing the menu system, we might have letters in rather than numbers. A, this. A, do this, execute this program. B, execute that program. C, execute that program. So what happens is, rather than you having to ask them to put in a capital A, or you checking to see if it's uppercase or lowercase, you can just tell them input A for whatever. If they put an uppercase, lowercase a, or an uppercase A, it's going to still execute that particular section of code. If they put an uppercase B or a lowercase b, it'll execute this portion of code. If you put a lowercase c or uppercase c, it'll execute that portion of code. So you see how sometimes you might have it grouped to where you have multiple cases, and if those cases, hey, do this, all right? Well, because you could say, okay, input a character, and then you want to check to see if it's a vowel or a consonant. So if it's a vowel, you could check for vowels, A, E, I, O, U. Okay, put A, E, I, O, U, and if it's not one of those, then okay, well, it's a constant, all right, a constant. So it just depends on how you write your program and how you want to manage your data, all right? So that's how your case statement works. And look, switch, whatever's in the parentheses, okay, this is being matched to this is being matched to that. This is being matched to this, being matched to that, whatever's in the case, all right? All right. Okay, say using it in a menu system. All right, we wrote a menu system where I add a choice, but it was just inputting a choice. But now they have it to where they have a case statement. Pretty much that same program we looked at the last time. But if you look at this one, this is your menu. Standard adult membership. All right, where's main menu? Okay, yeah, health club membership menu. Then 1, standard adult menu. 2, child membership. 3, senior citizen membership. 4, quit. And then enter your choice, CN choice. So once you input your choice, look at this case switch statement. You have switch choice. So whatever choice they put in, 1, 2, 3, or 4, and remember choice is of what data type? I think it's, they made it sure. Let me make sure. Yeah, no, they made it int. So still, they made it int. So what? You don't put the what? You don't put the double quote. They didn't use the variable. They used the constant because they made adult choice equal to 1, child choice equal to 2, senior choice equal to 3, and quit equal to 4. So 1, 2, 3, 4. So if they put in a 1, all right, choice will be matched against adult choice, which is 1. So if it was 1, then they're going to see out how many months. Then they're going to allow them to input it. Then they're going to multiply the charges times the adult rate and then output what the charges is. And then break on out and they finish. If it was 2, all right, if choice was 2, all right, which was child choice, remember child choice here is equal to 2. So switch choice, and then child choice, if it's 2, it's going to fall here, and it's going to perform all of this in the same manner, input the number of months, calculate the fees, and then output the fees, and then break on out. So you see how the switch allows you to do a case rather than do if levels, if this, else if, else if, else if, else if. And you got them full levels of ifs, and now you got to try to keep track of your curly braces, where this loop starts and stops. Where with the case statement, all you're looking at, let me minimize that. With the case statement, all you're looking at, okay, if it's 1, I'm doing all this and then I'm breaking out. If it's 2, I'm doing all this and breaking out. If I want to add something in here, I can just put it wherever and there's no problem. I don't have to worry about curly braces where it start and stop. As long as I put it logically in the right place, I'm satisfied. But the curly braces in the if statement can get confusing as you get deeper and deeper and deeper into levels. All right? So, and like I said, a lot of this, programmer's choice. Because if you have 10, 15 levels of ifs, if your logic is in order, it's no problem. You know, it'll work. And then if you have the case statement, 12 different conditions for the case, it'll work too. So it just would be more or less programmer's choice, all right, of how what you like and how you like your how like to code, all right. So now, all right, more about blocks and variable scope. Now, class, this is kind of how would I say it? That variable scope can be very confusing because what happens is many times we might write code and we're like, okay, well, I created my variable, I gave it this value, but when I'm outputting it, it gives me a different value. All right, that's because you can have a variable and then reintroduce that variable in a different scope, and it can give you a different result in that scope, and then it returns to its original value in another scope. All right, so all right, this program demonstrates late variable definitions. All right, so all this saying is what they're doing is rather than declaring their variables at the beginning, they declare their variables right before they use them. All right. Now, some people program that way, but most times when we program, we tell you, hey, come up with all your variables, state your variables at the beginning, you know, of your main function or whatever. And sometimes if they're global, so that what? They're all there, and you won't run the risk of having undefined variables or whatnot. But say we look at this program, we got two constant variables, min income and min years. And remember that program was where a person had to have so many years and then so many college years on the job, and the income had to be a certain amount. And then, well, this is a different one. But remember, the last one was so many college years, so many years in college, and then so many years on the job, certain salary. So let's look at it. So how many years did you work? All right. But let's see what happens here is if we look at it, look where they introduce years. All right. And normally when we write our program, we'll introduce all our variables where up at the top of the program. But what did they do here? They introduced years right before they inputted it. How many years did you work? And then they introduced it here. Now, what can happen is if you all of a sudden try to put this in a loop and then you keep doing int years, you could run into issues because you're trying to keep if it's in a loop, you're trying to do int years every time, so it might cause issues. So you put it out here, you got your years allocated, and then you always could set it back to 0 and do whatever. All right, but like I say, it just depends on you as the programmer, what the program is doing, number one, and you as a programmer, how you like to code. All right, but they introduced the years at this point. All right, but the program is never coming back to execute years or whatnot. So that's what they're talking about, late variable definition. All right, but let's continue on and look at it. It says it is a common practice to define all of a function's variables at the top, which we kind of try to teach you so that you have them all there. You have an issue with one or something, you look at the top, oh, these are my variables. Either more easier to debug or whatnot. But is it right or wrong? No, it's not. Programmer style. All right. So sometimes, especially in longer programs, it's a good idea to define variables near the part of the program where it is to be used. All right. And our programs aren't that large, and our programs normally deal with specifics and okay, this, okay, I got that, and move forward. All right. This makes the purpose of the variable more evident. Okay. Now it's being introduced. Hey, oh, wait a minute, it's going to be used. All right. So, and like I say, in the previous programs, we did whatever. So it says the variable income and years are defined inside the function main brackets, okay? Variables defined inside a set of braces have local scope, all right, or block scope, all right? They may only be used in parts of the program between their definition and the blocks closing braces. All right. So if we look at this, all right, when it says that, okay, we have our main, but let's see, right? So everything is defined within here. So as long as it's defined within here, it can be used. All right. So that's what it was saying by that. But we're gonna see later on that depending on how you define something, it can only be used within that block. So it say this program demonstrates a variable defined in an inner block. All right. Now, remember this one was defined in, we have our main, all right, in year, all right, it's not enclosed in any other curly braces. So it's in what? The block of the main. I could use it anywhere in the main. All right. Now, it says this program, though, look what happens. In this if statement, I have an open curly brace, a closed curly brace, but where did I introduce year? All right. I introduce year inside of this scope here. You understand? So this is a scope. Year is not introduced here. All right. So what happens is year can only be used inside this scope. Where is that? Yeah. Inside this scope. Otherwise, you'll have some type of problem. All right. So it's introduced where? Inside the scope of what? If income is greater than or equal to min income. And what? Int year. And now I have it, and now I can use it. If I try to use year outside of here, outside this return, I'm going to get an error. So it said, notice the scope of year is only within the block where it is defined. The variable is not visible before its definition or after the closing braces of the block. So what? It's introduced here, int whatever. So opening curly brace, close curly brace. That's the only place, and I said here, but not here. Only from here, the opening and the closing, that's the only place year is known within the program. Anything else outside of that, I'll get an error. It'll say year not defined, don't know what, whatever. All right? So when a program is running, all right, and it enters the section of code that constitutes the variable scope, it is said that the variable comes into scope, okay? This simply means that the variable now can be used, all right? It's now visible by the program and it may reference it, okay? Likewise, when a variable leaves the scope, what? It's no longer used, okay? So if that's the case, now we can have variables of the same name used in a program, but in different scopes. And that sometimes becomes very confusing, all right? Or can be confusing, all right? So this program uses two variables with the, it should be same. Oh, they made an error. No. Yeah, with the same, no, with the name number, they did it right. With the name number, it should be, I thought it was in the same number, but no. So what happens is, in this int num or int number, the scope is from here to here, correct? Beginning block, ending of the block. But what happens is, inside of this if statement, what did I just do? Or what did they do? They just introduced a what? Another variable called what? Number, all right? That have a scope from where? From this open curly brace to this closed curly brace. Everybody see that? Int number here, and because I'm in a different scope, I can use that same variable name. Now, you say, well, that's not right. That can't be true. That can't. Okay, look what happens. They created a variable called num. Entered a value greater than 0. So, okay, they entered the number 2, all right? They fell into this scope. If number is greater than 0, 2 is greater than 0, right? So now int number, and they enter the number 7. See out, and then they outputted the second number. Okay, they outputted the second number, and outputted 7. But then when it fell out of the scope, right after that closed curly brace for that if, it outputted number again. It outputted number here, outputted number again, and it outputted 2. Why did it output 2? Because now once we fell out of this scope here, here, we back into the what? The scope of the main, where number was entered as what? 2. And so it outputted 2. Everybody see that? Everybody see that? Hello? What I could do, let's write a program and see, and see. So let's see some control X. So we do pound include. All right. So what happens is, and that scope also works when no matter how or where you're in the program, dealing with functions or whatever. So now I could do something like int, I'll say this whatever, val, okay. And I'll say cout. All right, and a value, all right? Then I'll say something like, and do just like them, if all right, so no matter what the, wait, not value, val. So no matter what the value, long as this is not 3, all right? Okay, I can say int val again, because what? Now I'm in a different scope, all right? And I could use the same, did I do a CN? No, I didn't do a CN. All right. All right. All right. So I could take the same information here, word for word, copy it, and paste it here. All right. But that, and you know, this time, okay, the value within the if, yeah. All right, value in main, but they have the what? Exact same what? Same variable name. Now, once I leave out of this if logic, I cannot print val. All right, I have to do whatever I have to do with val, this particular val, inside of this scope. Can't do anything outside. All right, so I could say cout. All right, value in if. All right. Okay. So, and then out here, I could just copy the same thing, but change if to main. All right. All right. So basically, oh no, I have to check. Basically the same program that they wrote. So let's look at it. We debug it because I already ran it. Okay, debug it. All right. So enter a value, the value in main. I'll say we do 200. Okay. All right. Enter a value within the if. I'll say 30. So see what happened? The value in the if is 30. Once we broke out of the if logic, it had to go back into the body of the main, and what? It knows that what? It didn't do anything to val in the main, and that value is what? 200. Okay? So that's all they trying to show you. When you're dealing with scope, because sometimes you'll be dealing with variables like, well, I created that value and I'll do it like this. This is what I'll do. I'll make this val 1, okay? I'll do this is sometimes what kind of error students get. Okay, make this val 1, right? So And I'm in here, and I'm dealing with this, all right? And I introduce a variable called val, all right? I'm gonna comment this out, okay? And so if I might have if whatever, do all this whatever, and then after a while I want to try to either do a mathematical expression or what is that? Yeah. Or something. And I say, well, I got val. I introduced val in this if statement. Why it's not being recognized? Only because what? It only is recognized inside of that scope. All right? Inside of that scope. You got to be able to understand that. Val is only recognized inside of the body of the curly braces, open and closed curly braces. Outside of it, we're dealing with val 1. You understand? Our program run with val 1. So sometimes that's the issue. But they showed it to you with the same name to show you whatever. But I'm just showing you how sometimes people would change a name and say, well, I inputted the value. Well, I could have left the CN in. Yeah. But still, I just created a value. And the thing is, I'm going to get an error because it does not know the outer scope of the main, outer scope of if does not know what the variable val is. And if I take this statement, this same statement, and I copy it and I paste it in here, I won't get an error. Okay. What did I paste it? No, I didn't. All right. See, I didn't get an error here, right? Well, I did paste it, but I didn't get an error here, but I still have that error here. And that's only because of the scope. And look what it say, identify your val is undefined. It's undefined being that it's out of the scope of the if statement. All right. All right. Any questions? Now, we at the end of the chapter. So anybody have any questions? Questions about the homework? Questions about the if logic or whatnot? Questions? No questions. So what I'm gonna do? Let's see. Let's look at that next chapter. The next chapter, and I'll just kind of briefly talk about it. And let's see where we at. Chapter 5. Chapter 5 dealing with the loop. All right. Dealing with loops. Was that the first? Yeah, okay. Right. Top of it. All right. So loops. I hate to use that bar again, it's gonna go too fast. All right. So loops. What are loops? All right. What does loops allow you to do? Now you're going to have to be concerned with the incrementing and decrementing of variables, whatever, because of your conditions of loops. All right. So we should know, and like I say, we never really talked about it, but the plus plus and the minus minus, all they are another way of saying a variable is equal to the variable plus 1, right? If I do this, well, I can't, what more am I? Okay. This here is equivalent to this, okay? Num plus plus is equivalent to num equal num plus 1, right? This is, in a sense, equivalent to num plus equal 1. That's num is equal to num plus 1, right? And the same thing with minus minus. Num equal num minus 1. Num minus equal 1 is num equal num minus 1. And num minus minus is the same. Num equal num minus 1. Taking away 1 from number. All right? Now, it tells us that our example so far showed the increment and decrement operators used in post fix mode, okay? Which means that the operator is placed after the variable. The operator also works in pre fix mode, where the operator is placed before the variable. Now, who could tell me the difference of it being placed in the front or in the back of the number? Anybody? What's the difference? What is the difference? All right. So this tells us in both prefix and postfix mode, the operator adds one or subtracts one from the operand. But I'll tell you the difference is the one we've been using, postfix, it evaluates the expression on that line, and when the compiler moves to the next line, that's when it actually increments the value. Postfix will increment the value on that line and then solve the expression, okay? So you might say, well, Mr. Vesta, what you mean? You said something, it sounds pretty easy, but what do you mean? Okay, looking at this, let's take this. All right, so we have this expression, all right? And then I'll do the CL. Okay. All right, so if I do something like this, I'll change it to X, Y, and Z. X equals 3, Y equals 1, Z equals 4. It doesn't matter. All right, and then I'll say total. All right, so is that right? So if I do something like this, total is equal to X plus 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 Y plus 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 Z plus plus. What's the output for total? Hello, class? Hello? What would be the output for total? Anybody? Where my ink pen is? Okay, what I'm gonna do, let's see if I can do it. My ink pen, I got it right. All right, so anybody can tell me, I'll give them 5 bonus points. Hello? Anybody? You should be able to do it in your head. Anybody? You should be able to do it in your head.
I'm trying to.
Huh? Huh? What's the answer? What's the answer? All right. The answer is
I'm coming up with.
The answer is 8. The answer is 8. 3. Somebody got their speaker on. 3 plus 1 plus 4. And 3 plus 1 plus 4 is 8, correct? So let's run it. You might say, well, Ms. Vesta, you got the plus on there. You're supposed to increment. Well, what we said about that? So what's that? What it say there? It's 8. It's 8. Now, somebody have their speaker on. Hello? All right. So now what I'm going to do is I'm going to output X So what I'm going to do, I'm going to output X, Y, and Z. All right. So let's run this. No, let's see. Let me close this up. So let's look at this. I'm gonna make it, I don't know if you can see it. Let me do something. Okay, wrong one. All right. Okay, so let's run it. So let's see. So val 1 is equal to what? 8, right, class? But let's look at this. X is equal to 4, Y is equal to 2, and Z is equal to 5. 5 plus 4 plus 2 is what? 11, right? Right, class?
Yes, sir.
But why do you think val is equal to 8? I want you to understand this because, like I say, this is going to help you understand a lot of expressions that you may see with pre or post operands on them. All right. Remember when I told you the difference between pre and post operator? What happens is, being that this is post, it's going to solve the expression before adding 1 to each one of those variables. So X is 3, I'm gonna use 3. Y is 1, I'm gonna use 1. Z is 4, I'm gonna use 4. So 3 plus 1 plus 4 and give total of value. And then when I leave this line, when I leave this this expression here and go to this next line, that's when the compiler gonna increment 3 to 4, increment 1 to 2, and increment 4 to 5. Only after it executes that line of code. Everybody understand what I'm saying here? That's post, all right? But let's take this same expression, but this time we're gonna do plus plus on each one of them. So now, what would the answer of val be? Oh, I messed up this one. So now what would the answer of val be? Or val 1? $11, because the pre says go ahead on and do the work or do the addition and whatnot before or while you're on that line. So what? The pre says solve this expression and while we on this line. So what? 3 becomes 4 plus 1 becomes 2 plus 4 becomes 5. So it solved 4 plus 2 plus 5 to give me 11. That's very important because the thing is, I could take this and say, okay, now what's the answer? What's the answer to this expression?
Should be 10.
Right. What 4 plus 0 plus 1, right? 4 plus 1 plus 5, which is 10. Correct. Because what happens is this will not decrement until after, right? Correct? So your answer should be the 10. Yeah. Okay. Right. So, all right. Everybody understand that? Everybody got that. So now, another thing, what could happen is, well, like I said, you probably wouldn't want it though, but it could happen when you have plus x. So what happens is now x becomes what? Here I'm incrementing, it becomes what? 4. Here I'm incrementing, it becomes what? 5. So what happens is this would be 5 plus whatever. So let's see, 5, and that's 0, plus 5 plus 5 should be 15 if I'm getting my math right. 16. Oh, I'm off one. So this plus this, that's 4. Okay. So 4 plus 1, that's 5. All right. So 5 and 5 is 10. So Z is 4 and 1 is 5. So why is it 15, 16? I'm not seeing why it's 16. Because 5 and 5 is 10. I'm adding this twice. And then I'm adding this, which is 5. And this, oh, that's because 1. Because this is not decremented until after, my fault. So I am getting 5 plus 5 plus 5 plus 1, and this decrement doesn't happen to go to 0 until we leave that line. So that was on me. That's why you get 16, all right? So you see how anywhere I got a plus, I got to make sure I increment it in all those stages before I try to solve my expression. I can't say, okay, 3 plus 1 is 4, so 4 plus 1, that give me 5 here, and then 5 plus 5 and got 15. No, I have to say, okay, plus x here, that's 4, plus x here, that's 5. 5 and 5 is 10. 4 and 1 is 5, plus 5 is 15, and this is 1, and that's 16. All right, so that's, like I say, you're dealing with pre and post, and you got to be able to understand this, you know, in a especially programming in the C++. Okay, you're gonna have to somewhat kind of understand it. So look, here's a little sample program. All right, we done kind of went beyond somewhat what they was talking about, but look at this. This is kind of like say num is equal to 4. So it says, okay, the variable in num is, and we know it's 4, all right? The variable num is 4. Okay, I will increment num. So what they did is num plus plus, on that line, it's still 4. Once we leave that line, it becomes 5. So on this line, num is 5, all right? So now I will increment again. Num plus plus on this line is 5, but when you get to this line, it becomes 6, all right? So num is 6. Now it says it's gonna decrement. Num minus minus on this line is still 6, but when we get to this line, it is 7. 7. It's 5, okay? Then we get to here, this line, minus minus num is 5, but it becomes 4 on this line. Oh, I messed up here. So it becomes 4 on this line, and then it outputs 4. All right. So that's how the plus plus minus minus work. But this one, the post, actually give it the value on this line as opposed to the prefix actually affects it on that line that it's on in the current time. Okay? So that's all, to say, you got to remember that. All right? Now, the difference between postfix and prefix, we just talked about that, but let's see and let's go over it. Num is equal to 4. See out num plus plus. What is going to output, class? It will output 4. All right? And if I do plus plus num, it will output 5. You ask, well, why would it do that, Mr. Sylvester? Because prefix, postfix says do it after I leave the line. So if I do see out, if I do Z, all right, and then Z plus plus, it's going to output 4. All right, it's going to output 4 because what? Z will not change to 5 until this next line. All right, so let's output it. All right, so when I debug it, it's going to output 4. All right, see, it outputted 4. But this same statement, if I do this, if I do plus plus Z, now this says affected, make the changes before I do, well, while I'm on that line. So now Z gonna become 5. It's gonna output 5. You see what I'm saying? Same statement. All I did was move the operators at the beginning or the end, and it can affect the results of your program. All right. So it can change what your values are. So that's basically what they are saying at that point. All right. So and then another same thing again, num is 4. See how num plus plus, it still outputs 4, but now it's 5. See how it's 5. Or num plus plus on this line is going to be 6. All right. And so because it's the pre. So basically the same thing we was talking about, pre and post. All right. So when you look at an expression and you see this like that, oh, what that mean? That's not a plus. It is. That means add 1 to it. But at this time, y gonna equal to the original value of x. When it move, when the compiler goes to the next line, then x will be incremented by 1. All right. So x will not increment by 1 until it goes to the next line in postfix. But if it was prefix, then it would affect x and then be assigned to y. All right. Which is pretty much this one. X is 1, int y is equal to plus plus x. That means y is equal to 3. I mean 2, my fault, 3. So 1 plus 1, it's gonna do it now, and then now it's gonna assign it to y. In this one, plus plus as post, x is 1, so it's gonna assign 1, then the next line x become 2. Okay? All right. We pretty much done mathematical expressions already. If A is 2 and B is 5, A times B plus plus is gonna give us what? 10. All right, everybody understand it. It will give us 10 because B plus plus, that's postfix. So you don't do anything to B on that line. B will be affected when it gets to the next line where it's gonna print out what? 2 and 6. We know 2 and 6 is not 10. But what? On this line, B was 5. 5 times 2 is 10. Then it increments B, and it printed out 2, 6, and 10, which 2 was A. 6 is B when it incremented here, and then 10 was the 2 times 5. All right. Now, but if it was this statement, then that would change our expression because it would have to add 1 to B before it multiply. So you see the order of precedence, it will do this before it multiply, add, subtract, and divide. So A times B plus plus, B, so you got to do the B plus plus first. So B plus 1 would be what? 6. 6 times 2 will give you the 12. All right? But now look at this. This is an error. You can't do the plus plus on an expression. all right? Only on those individual variables, okay? You can't do it in that fashion. Yeah, you get an error. But look here, if x plus plus greater than 10, that's valid because x could be equal to 5. Is x plus plus at that time 5, but then when you come out and come back, when you come out, x could be another value, but then when you come back here, now it's 1 plus. It could be x6 is 6 greater than 10. So you understand, after it leaves it, it increments. It don't increment on that line. All right. Now, we talked about increment, decrement, whatever. Now, the reason we talked about it is because what loops does, loops allow you to perform a series, one or more lines of code multiple times. And those multiple times has to be sometimes tracked by a steady increment, a steady decrement, till you reach a certain value, etc. And normally that's done with a value being incremented using the plus plus or decremented using the minus minus. So that's why we kind of went over that part. So a loop, all right? What is a loop, all right? In this class, we're gonna talk about the loops, the while loop, the for loop, and then they got the do while, do until. It's kind of the same, but it's the way you ask the logic, okay, which makes them a little different. All right. So let's look at the while loop. The while loop says, in a sense, rather the if statement, if this is greater than this, do this. A while loop says while a certain value is less than, not equal to, greater than equal to, less than equal to something, do this, all right? So it's almost like you're trying to reach a goal, right? You're trying to get to a certain point. If you never get to that destination, the computer will tell you that sometime at a timeout, or sometime you'll just be stuck, where it's just running the same series of statements over and over. That's called an infinite loop, all right? Let me give you an example of an infinite loop with a while, all right? Not here. Yeah, I was right. With a while loop. So let's do this. I'll say int x equals, say, 10, all right? Then I'll say while, and this is the format, x is greater than 10, all right? Or not say greater. Well, I'll say greater than 5. While x is greater than 5, all right? And what I'll put the curly braces. I'll say Cout this is a test. Well, I'll let it run on. I'll do it that way. So I'll say this is a test. So let's run this. So first of all, let me ask you this. How long you think it will perform this information here? I'm telling the computer x is equal to 10. And then I'll say while x is greater than 5, do this. All right, I want to do this. How many times will it do this statement? It will do it an infinite number of times because x will always equal to what? Look, it'll always equal to 5. So it'll just keep running and running and running until either some compilers, what they'll do, they'll say, oh, you're using too much memory without processing. Well, timeout, So look at the bottom. You see how the program is just steady running. There's nothing gonna stop it but me doing a Control-C or something to break it. So what do I need to do? I need to try to make x increment to get to 10, right? Or get to or some kind of way, or whatever. well, x is equal to 10 is 5 greater than 10. Well, that's kind of confusing. So let's say x, yeah, okay. All right. So normally what you do, let's say set x equal to 0. I'm going to type x is equal to 0. Now, I'll say while x is less than 5, all right? So while x is less than 5, I want to do this. Now, that'll work infinite also. But if I go in here and say x plus plus, all of a sudden now, the first time through x is 0. Is 0 less than 5? Yes. Increment x. X becomes what? 1. Is 1 less than 5? Yes. Increment is 2 less than 5. Yes. Increment is 3 less than 5. Yes. Increment is 4 less than 5. Yes. Increment is 5 less than 5. No, kick out. So you see what I'm saying? I have to try to make it to where I'm trying to reach that point. Otherwise, if I go the negative route, if I do minus minus, then I'm doing the infinite loop because I'm going in, infinitely to the negative side of my line, number line, all right? So I'll do plus plus and watch what happens. This time I'll put n line in it. All right, so now let's run it. We'll debug it. Bam, 1, 2, 3, 4, 5. It started at 0, 0, 1, 2, 3, 4. So everybody see what happened. It reached that plateau. But if I go back in and I put a minus minus, what happens the first time through, x is 0. Okay, it's gonna print minus minus. Okay, negative 1 gonna be less than 5. Print minus minus. Negative 2 less than 5. Negative 3, but I'm never getting or trying to reach 5. So what's gonna happen is that's gonna be an infinite loop. See what I'm saying? So it's just an infinite loop, printing and printing and printing until either the system times out or I actually do the control, I did a control C or some kind of break or they call it an interrupt to interrupt that process on the system, all right? So that's what a loop does, okay? And many times we may use loops to read data in from a file while not in the file. We might use a loop if we know the number of inputs we need to input. While X less than 5 CN employees, well, I'm gonna input 5 employees, or whatever it may be. But that loop, I have to pretty much know how many times I want to iterate that loop or perform those series of statements in that loop, all right? And that loop will perform those statements. Now, another factor or important thing about a while loop, as long as the value is less than 5 in this instance, it will fall into the loop. But if I said x is equal to 10, while x is less than 5, will it do any of this? No, it will not. So if you want anything to perform within a while loop, your condition here has to be first met before anything is performed. So I set it to 10 and I'm asking if it's greater than 5. What you think gonna happen? Nothing's gonna happen. It's just gonna give me the prompt. See here? It didn't even execute the code inside inside the loop because it didn't meet the criteria. So what? It kicked out to the next executable, which is return 0, which ended my program. Okay? So those are some of the things you got to consider when dealing with the while loop. So it tells us a loop is a control structure that causes a statement or group of statements to repeat. All right? C++ has 3 loop control structures: the while loop, the do while loop, and the for loop. The difference between these structures is how they control the repetition. With a for loop, we specify the number of times based on our starting point and our ending point. The while loop, we gotta fall into it where we give a value then we ask if that value meets the criteria, and we fall into it and perform it if we want to perform it. The do while loop, what it does, it actually executes the code at least one time and then asks the question if while whatever is greater than or less than whatever, go back and repeat it. But it does give you at least that one execution of the code. All right, so let's talk about the while loop. All right, oh well, class is over. Let's see, the while loop. The while loop has two important parts. One, an expression, we saw that when we said x greater less than 5, that is tested for true and false values, and two, a statement or block, right, of statements that is repeated as long as the expression is true. All right, so all it's saying is, here's your for logic. Oh, well, not for, excuse me. Your while logic, while whatever is greater than whatever, or while whatever is less than whatever, while whatever not equal whatever. If that's true, we're going to perform these statements, come back, ask the question again. If it's true, perform the statements, come back again. If it's true, perform the statements, come back again. When it's false, then we're going to continue on with our program. Simple as that. So X number of times we're going to be reading the statements and performing, depending on the condition of the loop. All right? So the format, while, and in parentheses, the expression, and then open curly brace, close curly brace. But really, they say a statement because by default, that one statement is the one that it'll execute. But I always tell you do the body so you're not confused as to where it starts and where it stops and whatnot. Okay? So see it show here, if you have multiple statements, you need the curly braces. With single statement, you don't, but I would put them anyway in case you have to add to it. You're not confused as when and what and why. All right? So here's a program, all right? This program, int num equals 0, while number less than 5, all right? See out, hello. Now, what happens? After it executes this, it has to what? Increment. If 5 is not, if the number is not incremented, we're not moving toward the 5 mark. So that, therefore, we're going to be in an infinite loop. But as long as we creeping, however slow, toward 5, we eventually gonna get to 5, and the program will continue. All right. But if we never advance or move toward advancing to get to a 5, then we're gonna be in an infinite loop. All right. We'll be in an infinite loop. All right. So, class, any questions? So I put well not. Yeah, I'll pose the test. That's test what? 4, huh? Yeah, I'll post the test and everything. Anybody have any questions? Any questions? Hello? Going once? Going twice? All right, so if not, finish up on your assignments. Go ahead and do your assignments. Make sure you do your programs, get them right. And then, like I say, take the test. I'll post the quiz also if I haven't already done so. And I'll see you on next class period. And you can start looking up at loops and see, get familiar with it so we can move forward. All right, so I'll see y'all on next class period.
Yes, sir.
All right.
All right, thank you.
All right.
Thank you.
All right.